Venus, the second planet from the Sun, is often referred to as Earth's sister planet due to its similar size and composition. However, its orbital characteristics set it apart as a unique celestial body in the solar system. This report delves into the intricate details of Venus's orbit, exploring its shape, duration, inclination, and other critical parameters. By examining these factors, we gain a deeper understanding of Venus's place in the solar system and its dynamic relationship with other celestial bodies. Venus's orbit around the Sun is remarkable for its near-perfect circularity. Among all the planets in the solar system, Venus has the least eccentric orbit, with an eccentricity value of only 0.07. This means that the difference between its closest approach to the Sun, perihelion, and its farthest distance from the Sun, aphelion, is minimal, measuring just about 1.5 million kilometers. For comparison, Earth's orbital eccentricity is 0.0167, which results in more noticeable variations in distance from the Sun throughout the year. The semi-major axis of Venus's orbit measures approximately 0.723 astronomical units, AU, equivalent to about 108.2 million kilometers or 67 million miles. This places Venus closer to the Sun than Earth, which orbits at an average distance of 1 AU, 149.6 million kilometers. The relatively small size of Venus's orbit contributes to its consistent solar exposure and plays a role in its extreme surface temperatures. The nearly circular nature of Venus's orbit is significant because it minimizes seasonal variations in solar radiation. Unlike Earth, where changes in orbital distance contribute to seasonal differences in temperature and climate, Venus experiences relatively uniform solar heating throughout its year. This uniformity is further amplified by its dense atmosphere, which traps heat through a runaway greenhouse effect. Venus completes one full revolution around the Sun in approximately 224.7 Earth days. This period, known as its sidereal orbital period, is shorter than Earth's year, but longer than that of Mercury, making Venus the second fastest planet in terms of orbital duration. The planet's mean orbital velocity is about 35 kilometers per second, km/s, with slight variations depending on its position within the orbit. At perihelion, when Venus is closest to the Sun at a distance of about 107.48 million kilometers, 66.8 million miles, its orbital velocity reaches a maximum of approximately 35.26 km/s. Conversely, at aphelion, when it is farthest from the Sun at about 108.94 million kilometers, 67.7 million miles, its velocity decreases slightly to around 34.79 km/s. These variations are minor due to the low eccentricity of Venus's orbit, but are consistent with Kepler's laws of planetary motion. The relatively short orbital period of Venus means that it completes nearly 2 orbits around the Sun for every 3 Earth years. This resonance has implications for observational astronomy and interplanetary missions, as it influences the timing and geometry of close approaches between Earth and Venus. The inclination of Venus's orbit relative to the ecliptic plane, the imaginary plane defined by Earth's orbit, is approximately 3.39 degrees. This modest tilt means that Venus's orbital path deviates only slightly from the plane in which most planets orbit the Sun. As a result, transits of Venus across the Sun's disk are rare but predictable events that occur when Venus passes directly between Earth and the Sun along this inclined path. In addition to its orbital inclination, Venus exhibits an unusual axial tilt of approximately 177.36 degrees. This means that Venus rotates on its axis almost completely upside down, compared to most other planets in the solar system. Combined with its retrograde rotation, where it spins in the opposite direction to its orbital motion, this axial tilt results in unique day-night cycles on Venus. A solar day on Venus, the time it takes for the Sun to return to the same position in the sky, lasts about 116.75 Earth days. This is shorter than a sidereal day on Venus, the time it takes for one complete rotation relative to distant stars, which lasts approximately 243 Earth days. The retrograde rotation also causes the Sun to rise in the west and set in the east on Venus. a phenomenon opposite to what we experience on Earth. One intriguing aspect of Venus's orbit is its resonance with Earth's orbit. Over an 8-year period, Venus completes almost exactly 13 orbits around the Sun, while Earth completes 8 orbits. This 13.8 resonance results in a predictable pattern of close approaches between Earth and Venus, known as inferior conjunctions. During these conjunctions, Venus can appear as either a brilliant morning star before sunrise or an evening star after sunset, depending on its position relative to Earth and the Sun. The regularity of this resonance has been known since ancient times and was used by early astronomers to track Venus's movements across the sky. The resonance also has practical implications for space exploration. Missions to Venus can take advantage of these predictable alignments to minimize travel time and fuel consumption during interplanetary transfers. For example, spacecraft, such as NASA's Magellan mission and ESA's Venus Express, utilize these windows for efficient launches and arrivals. Venus has been observed since antiquity due to its brightness and proximity to Earth. Ancient civilizations such as the Babylonians meticulously recorded its movements across the sky, recognizing patterns in its appearance as a morning or evening star. These observations laid the groundwork for later astronomical studies that revealed details about Venus's orbit. In modern times, radar observations have played a crucial role in refining our understanding of Venus's orbital characteristics. Radar signals bounced off Venus's surface have provided precise measurements of its distance from Earth at various points in its orbit. These data have been used to calculate parameters such as orbital eccentricity, inclination, and velocity with high accuracy. The study of Venus's orbit has also contributed to broader insights into planetary dynamics and celestial mechanics. For example, comparisons between Earth's and Venus's orbits have highlighted differences in their interactions with other planets and their responses to gravitational perturbations from Jupiter and other massive bodies. Venus's orbital characteristics make it one of the most fascinating planets in our solar system. Its nearly circular orbit minimizes seasonal variations in solar radiation, while its short orbital period ensures frequent alignments with Earth that facilitate both observation and exploration. The planet's modest inclination and unique axial tilt add further complexity to our understanding of its dynamics. As we continue to study Venus through telescopic observations, radar measurements, and spacecraft missions, we gain not only a deeper appreciation for this enigmatic planet, but also valuable insights into planetary formation and evolution processes throughout our solar system.